Hi everyone, in this problem we are going to find out the component of a vector in a three-dimensional case. Say you have a vector which is a force is given, which is the magnitude is 475 Newton in this three-dimensional axis. This is your x-axis, this is y-axis, and this is the z-axis. This vector creates an angle 54 with that z-axis, and this is actually, this line is showing the shadow of this vector f in the xy plane, or you can say the component of vector f in the xy plane. That component create a 33° with that positive x-axis. I have to find out the component of this vector along to the x direction, along to the y direction, and along to the z direction. Okay, fine, let's start. So remember, to find out the component of a vector is basically we take that shadow, right? Say if you think about, say I'm going to draw for you, say I have these two axes, so I have a vector, this is the vector A. So if it's create an angle over here theta, say this is the vector A, then you will find out two components. One will be towards that direction, which I say this will be the x component, since this is this is x component, x-axis, and this is actually y-axis, and this one will be basically that a y component. And that is the reason if I multiply this ax by unit vector ax I hat, that would be a that vector, and if I multiply that one by that unitary vector along with the y direction, which is j hat, and this will represent that vector. Now this ax I hat and ay j hat head to tail connection, we can say that the resultant vector a would be basically ax I hat plus ay j hat. Using the vector triangle law, we can find out that vector. Fine. Now how I'm going to find out that component of ax? Now if we think about in terms of magnitude, so I say this is actually your ax length and this is actually your ay length, then this will be your resultant vector a, right, which is I'm considering in terms of magnitude. Then this is actually that right angle triangle, this is actually your 90°, this angle would be theta, then I can say this angle would be 90° minus theta. Then we can use the trigonometric definition to find out, say that ax, we can write down the cos theta would be ax by a. It means that this ax would be a cos theta. Remember, this one, to take the component, always you have to take the cosine ratio. The sine ratio comes automatically. You will find out, say for that this ay component, I'll consider this is my angle, right? In that case, ay would be the base. Now for that one, we can write down cos of 90°, sorry, cos of 90° minus theta. This will be the base. In that case, base is ay by a. Then I'll find out that ay would be a cos of 90° minus theta, which is automatically give you a sin theta, since cos of 90° minus theta basically that sin theta. So that's how actually we can find out the component over there. You don't have to take that sin theta, because this one always give you the sin theta if the angle is 90° minus theta, right? That we know from the trigonometric ratio. So to find out the component, always you have to take the cosine ratio, never take that sine ratio. Sine ratio basically will come from here, 90° minus theta. Remember this idea. This is very important idea to find out the component of a vector. Using that idea, I'll find out the component of this vector, because that vector f create an angle 54 with the z-axis. Then I can say this vector fz would be the component, there should be that f cos of 54 degree right? Any vector create an angle with any axis, we'll always take that cosine ratio. So that's why I write down f z component would be f cos 54. I know that this f z because I know that f is 475 Newton, so I put it over there. 474 into cos 54. If you do that, then you will find that it will be 279.19 Newton. So this is will be that the component of vector f along to the z direction. Fine. So this is one answer. Now, if we create one component towards that direction, which is f of z, you can use a different color so that you can understand. So if you put on a light on that case, you'll find out. Sorry, say you can draw in a 3D view so that you can understand. So this is will be basically your f of z component. Now I can also find out one more component which would be in the xy plane. That component with that one. So this is which create an angle 90 degree minus theta, right? So this component would be f of xy. I write down the xy because this is actually in the xy plane. So that's why I write down f of xy. Now I can find out that one. So then what would be the case? I can write. Now you can write. Now f of xy would be basically f of cos of 90 degree minus theta, right? Because this total angle, we know that because these are actually the right angle triangle, right angle axis coordinate system. That angle is 90 degree. If this is theta, then this is going to 90 degree minus theta. Then I can say this f xy would be 475 cos of 90 degree minus theta is basically 54, right? This one automatically give me f of xy 475 sine 54. Now we can find out this f xy would be 384.28 Newton. So this is actually that component of force F in the xy plane. Now this with this F of xy plane, this one create an angle, this 30 degree. Now I can use that one, right, for the x-axis. Now if you say the x component, because I can draw over here, so this is your x-axis, this is actually your y-axis, and this is basically your fxy, which create an angle with the x-axis actually that 33 degree. Now again I will use the component method for x component. I can write f of x component would be f of xy cos of 33 degree, because theta is 33 degree. Then I will find out the x component be f of x actually the 384.28 into cos 33 degree, which will give you 322.28 Newton, and y component f of y would be f of xy cos of 90 degree minus 33 degree, because that angle would be 90 minus 33 degree, right? So that's how we can write down this f of y component would be f of xy sine of 33 degree. Now I know f of x actually 384.28 into sine 33 degree. That will give you that f of y component would be 209.29 Newton. So that's will be that component. So that means we can write down that f of x component is 322.28 Newton. F of y component actually 209.2 Newton, and f of z component is 279.19 Newton. This will be the answer of this question. Okay, thank you very much.